Welcome to my session, DBA Mythbusters. It's one of my favorite sessions. I've done it a couple of times at SQL Connections. I've never done it here at PASS, so I thought it would be a good thing to do as a spotlight session because I can debunk a ton of stuff that you might think is true but actually isn't true. Okay? Some stuff that I'm going to talk about you might think is false but it's actually true. So we're going to run through a whole bunch of myths and misconceptions. Now, if you don't know who I am, my clicker would work. Ooh, it would help if I switched over to my laptop. See, I've never done this before. There we go. If you don't know who I am, my name is Paul Randall. I used to work for Microsoft. I was on the Microsoft... You can't hear me at the back? Sounds pretty loud to me. We've got these trumpets. Anybody got hearing trumpets for people at the back? No? I can't go any louder, I'm afraid. I used to work for Microsoft. I started off working for DEC, worked for DEC for about 5 years, then joined Microsoft as a developer on the SQL storage engine team. For 2000, I wrote things like show config, index defrag, bits of CheckDB, login and recovery, bulk load, all that kind of good stuff. For 2005, I rewrote all of CheckDB and repair, which is my main claim to fame. And then took over as what's called a development lead of one of the core storage engine dev teams. When we shipped 2005, I decided I was kind of bored writing software, so I changed to be what's called a group program manager of the storage engine. So I was responsible for the whole storage engine, deciding what gets built rather than how the stuff gets built. Did that for a couple of years and then decided I liked doing the talking to customers, consulting and presenting more than I liked building software. So I decided to leave, join my lovely wife Kimberly, running SQL skills. So that's what I do now. Now that's all the boring stuff. The interesting stuff down at the bottom, I do like sheep, as many of you well know. On... Bah, thank you very much. What's that? Yeah. The blogs. So we blog an awful lot on SQL skills. There's no advertising, marketing, any of that kind of junk, just lots of free information. Who reads either of our blogs already? Excellent. Email. So I always like to say, if you're in a session of mine or a class of mine, you have free reign to send me email. It's probably a bit dangerous saying it to 500 people, though. Please send me email. I love to hear questions and concerns you have about SQL Server. I will reply to you. It might take a few days. I might just point at a white paper, but you will get a reply of some kind. Twitter. Who's on Twitter? Excellent. So we're all on Twitter. A bunch of the MVPs and so on are on Twitter. There's a very vibrant SQL community there. There's this thing called a hashtag, #SQLHelp. If you can frame your question in 140 characters or less, send the question and put #SQLHelp on the end. And a bunch of people like me and the MVP sitting up here at the front will respond to you with some answers. Okay? Very cool stuff. Anyway, on with the show. So the reason that this is important is there's an awful lot of interesting, incorrect information out there, which can cause you problems. The very worst case, it can cause you to actually have downtime, data loss, waste a whole bunch of time, waste a whole bunch of money, trying to do something that's actually not possible. Okay? So what I want to do today is I'm going to run through about 35 myths and misconceptions, and I'm going to explain whether the myths and misconceptions are true or false, and I'm going to explain some background about them as well. Okay? So we're going to do a trial run first, just to see how things go. So this is our trial. What do you think, true or false? It depends. It depends is a good answer, actually, Tom, yeah. Okay, so this one's obviously busted, okay? All right? Now let's get on to the real ones. Number one, when a database snapshot is created, it makes a complete copy of the database. True or false? Excellent. It does not make a complete copy of the database. So the way that snapshots work is they use a thing called NTFS sparse files. Same kind of concept as if you're programming and you create a thing called a sparse array in any programming language. You can define an array that has, say, 100 million elements in it. But the only elements that take up memory are the ones that you actually populate. The same thing with an NTFS sparse file. What SQL Server does is whenever a page in the source database is just about to change, the buffer pool will push the pre-change image of that page into the database snapshot. So the combination of all the pages in the source database that haven't changed since the snapshot was created, plus all the pages that exist in the snapshot, taken together give you a point-in-time, transactionally consistent view of that database. Okay, that's how a database snapshot works. Now there's a little twist. The twist is that not only does a database snapshot not make a complete copy of the database, it also doesn't reserve any space. Now, if you create a database snapshot, it looks like, say you've got a 200 meg database. You create a database snapshot, you look at it in Windows Explorer, the file that you've created says, I'm 200 meg. But it's not. It's just presenting itself as 200 meg. If you actually right-click and look at properties, the size on disk will be a small number of k. That will grow as more and more pages get pushed in there. Now, the fact that a snapshot doesn't reserve space means that you can have some problems if you're running CheckDB. CheckDB, under the covers, the way that it gets its transactionally consistent view of the database that it's checking is it creates what's called a hidden database snapshot. So not only does it create sparse files, it creates those sparse files as what's called NTFS alternate streams on your existing data files. Now, because these NTFS alternate streams are in the same location as your existing data files, and there's no space reserved, if you have lots of activity going on in your database, lots of inserts, updates, and deletes while you're running CheckDB, the snapshot's going to grow and grow and grow, and it's possible to run out of space, in which case CheckDB will fail. Okay. Workaround for that is create your snapshot somewhere else. It's just the same concept, really. Okay. Oh, by the way, please stick your hand up and ask questions, and if I'm looking at the board, just shout, "Hey, Paul." You're not going to put me off by asking questions. We've got plenty of time. Myth number 2, a suspect database can be repaired by detaching and attaching. If anybody gets this wrong, they're going to leave the room. Okay? True or false? Yeah. Denny knows nothing about SQL Server anyway. Okay, busted, of course, it's busted. Okay? So in 2008, you actually cannot detach a suspect database. They fixed it so you can't do it, which is fabulous. In 2005 and earlier, you can detach a suspect database. Now, suspect. In 2000, there was one database state, and it was suspect, which means that the crash recovery couldn't run. There's 2 states in 2005 onwards. One's called recovery pending, and one's called suspect. Recovery pending means, according to the boot page of the database, the crash recovery system knows that crash recovery has to run. In other words, the database wasn't cleanly shut down. Suspect means that crash recovery started but couldn't finish. Now, if you detach, or I should say, if one of your colleagues, because it's always somebody's colleague that does this, if one of your colleagues detaches a suspect database, then when you go to attach it again, the attach mechanism is going to say, oh, was the database cleanly shut down or not? If the database wasn't cleanly shut down, then to do the attach, it has to run crash recovery. Now, if crash recovery can't finish, it will fail the attach. Okay? So that's where you have to use the hack method that I described on my blog. A bunch of people have described it as well, where you create a dummy database with the same name, the same exact number of files with the same file names, shut that database down, rip out the files, drop in the corrupt files, start up the database, and now you've got a reattached suspect database that you can fix with emergency mode repair. Okay? Obviously, the best way to do it is to restore from your backups. But a suspect database cannot be repaired by detaching and attaching. Yes? Yeah.
And what they do, where I'm going,
I know where you're going.
is they will detach the database, delete the LDS, and reattach it. And that works. Will you explain why that's a bad idea?
So what Buck's saying is he's seen some people where if their transaction log has grown out of control, shut down the database, detach the database, delete the log file, and then reattach the database. Okay? Now, this isn't causing any corruption issues because the database was cleanly shut down. When you do the attach single file or you do the attach database and it builds the new log for you, okay, so if you do attach rebuild log, unfortunately, if your database log was really large, when you do the attach rebuild log, it's going to create a transaction log the same size. And unfortunately, even if you have instant file initialization turned on, transaction logs must always be 0 initialized. So you're not going to save yourself anything at all by doing that. So the way to recover from a log that's too large is allow the log to clear, so probably doing a log backup or a checkpoint. Allow the log to clear, then manually shrink the log file down, dbcc shrink file, and then manually grow it up again. Grow it in chunks of 8 gig, so you don't have too many VLFs and you don't have VLFs that are too large. Okay? If you have problems with your log, easiest way to fix them is go to Google or Bing and do Kimberly 8 steps. In both search engines, the first thing that will be returned will be a blog post Kimberly wrote, how to recover from an out-of-control transaction log. Okay? So you are useful after all, Buck. Occasionally. Myth number 3, backups cause blocking. Now remember, some of these are trick questions. Okay? Backups cause blocking, true or false? Ooh, somebody said true over there. Busted. Backups do not cause blocking. Okay? Backups don't take locks. What you may have seen when you take a backup, okay, and you see that all your activity essentially stops, is not that there's any locks being taken. It's that you've got such horrible contention at the I/O subsystem level that it appears as though your workload has stopped. But it's not. It's I/O contention. Right? You can very easily simulate this if you go to your laptop, create a large database, and create the database file and stick it on, say, your Windows drive, and then take a backup and have it back up to the same drive. Okay? You'll be bouncing the disk head around inside that laptop like crazy, and it will slow down any concurrent workload you've got. Okay? Backups do not cause blocking.
Is that different for VDI laptops like Lightspeed?
That should not be different for any tool that uses the VDI interface, like Lightspeed or other things. Okay? Essentially, they're using the same mechanism underneath. It's just a backdoor way of calling into the backup system. Okay. Myth number 4, instant file initialization can be controlled from within SQL Server. True or false? Now, if some of you that were in Bob Ward's session yesterday should know a little bit about this, because he talked about it yesterday. Yes and no.
Yes.
Okay. You cannot turn on instant initialization from within SQL Server. Okay? The only way to turn it on is to give the SQL Server service account, or the Windows group that is part of, the permission perform volume maintenance tasks, also known as SE manage volume name. Then you have to bounce the service. The service does a one-time check when it starts saying, do I have this permission? After that time, it will do instant initialization for data files. Now, there are some trace flags that you can use to alter the behavior if you already have instant initialization turned on. Trace flag 1806 will temporarily turn it off. If you turn on transparent data encryption in 2008, it turns off instant initialization. Now, if you only have SQL Server access to a SQL Server, you do not have Windows box access, you can test whether you have instant initialization enabled. If you turn on trace flags 3004 and trace flag 3605, then you create a dummy database. Go and look in the error log, and you'll see some messages in the error log. You're always going to see a message saying, I am zero initializing the log file for your dummy database. If you have instant initialization turned on, if you have instant initialization not enabled, you'll also see a message saying, I am zero initializing your data file. Okay, so that's the way that you can test from within SQL Server. Now, there's other ways, obviously, but they involve turning on XP command shell, which most corporations don't allow. Okay, especially if you've got auditors. As soon as you turn it on, boom, you've broken your whatever requirements for auditing. Okay. Oh, another misconception. In fact, this is quite funny. Instant initialization is enabled in all editions of SQL Server. And when SQL Server 2005 first came out, Books Online and all the various white papers said it was enterprise only. And I remember I was teaching what thing called the Always-On Bootcamp at the start of 2007. And I was explaining to the customers and consultants we had in the room on the Microsoft campus that this was enterprise only. And then somebody put their hand up. I think it was Peter Byrne put his hand up and says, actually, it's available in all editions because I wrote the code. Right. So it's actually available in all editions. Right. Online index operations. Unicorns and rainbows. Right. Yes?
Before we go back, why would you want to disable? You saw that you had a list on your slides. I'm curious to know why.
Why would you want to disable instant initialization? Well, okay, the reason that instant initialization is not on by default is because there's a very small security risk. Now, as soon as you say security risk to a bunch of people, they say, I'm not going to touch it ever. Right. The security risk is this. If you have a volume that's being shared by, say, a file server and SQL Server, okay, bad idea, yeah, boo. And say you've got this portion at the front is SQL Server files, so you've got this portion which is Windows Server files, okay, files. If these are kind of secure files with secure data in, I mean, that's a bad idea, right? And then you delete some of those secure files. NTFS does not do overwrite on deallocate. If SQL Server then grows one of its data files, it's going to pick up a portion of that volume that was used previously for those secure files. The bits and bytes, if you've got instant initialization turned on, the bits and bytes that were making up those secure files are still there. They're now part of your data file. So somebody with SA privileges can use DBCC page with dump style 2 to do a hex dump of those bits and bytes. Information disclosure. Okay, that's why it's not on by default, and that's why you might want to temporarily turn it off if you know that one of your databases has this potential for information leakage. Oh yeah, exactly. So Buck's saying it, and I agree. At that point, you're so far insecure, it's just not funny. Okay. But there were some customers when we initially put out 2005 for the IDWs and so on that had this situation. So it's off by default. Okay. Online index ops, unicorns and rainbows. So do online index operations acquire locks or not? See, you're not so sure of this one, are you? Okay. Yes, they acquire locks. No, it's not. It depends. They always acquire locks. Okay. Now, because almost online index operations is not a very good marketing term, we called it online index operations. Okay. But unfortunately, that's a bit of a misnomer. Okay. So if you think about what online index operations is doing, what it's going to do is it's going to build an index while the table is being used and while the index that maybe it's replacing, if you're doing an index rebuild, is having changes made to it. Right? So the reason the locks are required is right at the start of the index operation, there's a shared table lock queued up. And that's because all plans that are changing the table have to recompile to pick up a new special operator, which essentially does dual updates. In other words, it updates the index being rebuilt, and it updates the index that's under the covers, okay, being built. Okay? So you've got the old index and the new index. Any changes have to happen to both of them. Okay? So the shared table lock is queued up. Now, if you've got operations that are changing the table, that shared table lock is going to wait. And that means because there's a shared table lock in the queue, anything else that wants to start up and make changes to the table is going to block behind it. So you have a point here where you've got the potential for massive blocking. When the shared table lock is acquired, it's like really fast what it does. Okay? It bumps the schema version of the table, kind of simplifying things a bit, and causes all the write plans to recompile, and then it creates the in-build index. Okay? It also starts a point-in-time scan of that old index using the versioning system under the covers. Table lock is dropped. Okay? So for the long time that the online index operation is going, there's no locks. This is why the marketing team was happy to call it online index operations. Okay? But as some of you may know, it's not quite. Now, at the end of the operation, there's a thing called a schema modification lock taken. You could think of this as a kind of super exclusive lock. So that lock is queued up. Now, if there's anything doing anything to the table, that lock is going to block. Anybody else wants to do anything to the table, they're going to queue up behind the schema modification lock. So you have another point where you can have massive blocking. Okay? Again, once that lock is held, it completes the operation very quickly. Okay? But you do have 2 points in here where there's the possibility of large-scale blocking. So that means online index operations may not be suitable even for some of you that want to use them. If you want to be able to do truly online fragmentation removal, you might have to look at using something like alter index reorganize. Okay? You can use with stop at when restoring a full differential backup. True or false? Yes and no. You can specify it as part of the command. It's cheating, see? Yeah. But it doesn't do anything. The reason that it's basically a syntactical nicety. The reason that you can specify it as part of the command is because best practice when you're doing any kind of multi-backup restore sequence is if you want to do a point-in-time restore, use with stop at on every one of your backups, just in case you accidentally go past. Because there's no kind of, oops, can I just go back a couple of seconds? No. Start from square one and do it again. Okay? You also want to use with no recovery on every one of your restores. Okay? Just in case you accidentally forget, because of course, with recovery is the default, okay? Which is really nice. No, it's not. Okay? Now, any data backup, it's actually, even though you can use with stop at, it doesn't make any sense to be able to do a point-in-time restore to a point-in-time covered by that backup. Because any data backup, when you restore it, the point-in-time view that you get, or I should say the view you get, is as of the point in time when the data reading portion of the backup completed. So any data backup, let's take a full backup for example, the operations that it does a checkpoint first of all, to flush out as many dirty pages as possible. Keeps a note of the LSN of that checkpoint. Right? Then it reads all the data pages. Okay? It reads extents, but it reads all the extents that have one or more pages allocated at that time. Now while it's doing this, you've got transactions going on willy-nilly, no problem at all. When it finishes reading the data portion of the database, what it's going to go and do is read transaction log. It's going to read transaction log from the time at which the data reading portion of the backup finished, all the way back to the checkpoint. And in fact, if at the time the checkpoint was taken, there were any active transactions, it will go all the way back to the oldest active transaction. Okay? In fact, if there were any unreplicated transactions, it will go all the way back to the oldest unreplicated transaction. So a data backup always backs up transaction log. And that's so that when you restore the backup, all these transactions that were going on while you were reading the data get resolved, and you get a transactionally consistent view of your database. Okay? But you can't stop anywhere in between. It doesn't make any sense. So although you can do it, it's really meaningless. Myth number 7, CheckDB causes blocking. True or false? You're going to insult me if you get this wrong, remember. Okay. Nobody's guessing. Wow, you guys don't trust me anymore. Busted. It does not cause blocking. It did before 2000. In SQL Server 2000, we put in a mechanism that essentially runs crash recovery on the database. So how CheckDB worked in 2000 was, at the start of running CheckDB, it would flip a switch in the recovery system and disable log truncation. It would then turn on what's called replication-style logging. In other words, no matter what recovery model you're using, it does full recovery model logging. It would read through all the database, and then at the end of reading through the database, it would then go and essentially look at all the transaction log that occurred while CheckDB was running. Okay? In fact, all the way back to the start of the oldest active transaction. And inside CheckDB, it would run crash recovery on that transaction log, making changes to the bits of data that it had figured out describing the database. Very, very torturous code to write. Okay? I know more about how the transaction log works than I ever really wanted to. The problem with that, though, is that in the 2000 time frame, not absolutely everything that was necessary to figure out exactly what happened was logged. So there were a couple of cases where essentially I had to guess. Okay? And there were a couple of cases within those couple of cases where the guess would cause corruptions to be reported that didn't exist. So you might have heard the old mantra, on 2000, if you run CheckDB and it reports corruption, run it again. If it still reports the same corruptions, then you've got real problems. Okay? Because of that non-determinism, if you will, and because of the fact that that logging code was so horrible, I ripped it all out for 2005 and put in database snapshots, as I explained earlier on. Because database snapshots, by their very nature, give you a transactionally consistent point-in-time view of the database, just what CheckDB requires. So from 2000 onwards, CheckDB does not acquire locks. Okay? You can force it to take locks if you want. You can say CheckDB with tab lock. Okay? But by default, it doesn't require locks. CheckDB is just wonderful. You guys should know that. Okay? If I say so myself. An index fill factor is used by regular DML operations. True or false? False. Yeah. So what a fill factor is saying, I would like to leave space at the leaf level of an index because I know I have some kind of schema or access pattern that is causing page splits to occur. One of the primary causes of page splits is having a GUID as your high-order key in an index. Okay, so if you have a cluster key and it's a GUID, welcome to page split city, basically. Okay? Those of you that were in Kimberly's session yesterday will know all about GUIDs and how you shouldn't use them as index keys. But if you have an application or something that is already coded to use GUIDs as primary keys, anybody a SharePoint admin? Nobody's a SharePoint admin? Really? A few people, I'm sorry. Okay. I'm going to, yeah. So SharePoint, in its wisdom, uses GUIDs as the cluster key everywhere. Okay. So of course GUIDs, because they cause fragmentation, means that your SharePoint databases, if you have them, get horribly fragmented. Okay. There are many, many other applications that use GUIDs as well. So if you have one of these applications where you can't change the schema at all, or you can't add indexes, you can't change anything at all about the indexes, then you're going to have fragmentation. And the only thing you're going to be able to do to get rid of it is periodically rebuild your indexes or reorganize the indexes, or kind of stave off the need to do that quite so regularly by using a fill factor. So if any of you have databases where the third-party apps will not support you if you make any changes to the schema, a fill factor is not going to break that. So you can set fill factors on your indexes and not break your support agreements. Okay? So the fill factor is only applied when the index is built or rebuilt. Regular DML operations do not make any use of fill factor. Okay? If you have indexes that get so horribly fragmented that the upper levels, in other words, the non-leaf level, also gets fragmented, then you can use this thing called pad index. I don't see it used very often. And that will take the same fill factor that you specified and apply it to the upper levels of the index as well. Now, how do you come up with a good fill factor? If you have a set of data that's not changing, you want the fill factor basically to be 0. Don't leave any space. If you have data that is prevalent to having fragmentation, how do you figure out what the fill factor should be? There's no easy answer. What I tell my clients is pick a number, put it into production, and monitor fragmentation for a week or two. And maybe tune the fill factor up or down a little bit, or make your index maintenance happen more frequently. The number I usually specify is try 70% to start with. Tune it up or down. But you might have fill factors for certain tables, certain indexes that are pretty low. There's a customer that we have out in New York, and they have a 190 gig table with GUIDs as their primary key. They're obviously moving away from that. But they have such performance problems from the page splits occurring that I have that table, that clustered index, set at 50% fill factor. Okay? So that during their regular day, they're not taking a perf hit by page splits occurring. Now, they have a lot of extra disk space. They have a lot of memory. They have a 128 gig machine. So they can afford the wasted space, if you will, from having a lot of a big fill factor. Because if you think of what a 50% fill factor is doing, it says every page 50% full. So that means you're taking twice as much space to read, twice as much space to store the stuff on disk, twice as many IOs to read the stuff into memory, twice as much memory in the buffer pool to store the stuff. Because an 8K page, even if it's only 50% full, still takes up 8K of your buffer pool. Okay?
That doesn't affect the backup size?
Backup size is not affected by anything you can do with fill factor. Well, okay, let's clarify. If you have a table that you specify a low fill factor for, then you're going to make it take up more space so that your database is going to be bigger, so your backup's going to be bigger. But a backup is not going to essentially compress any of that wasted space out unless you use backup compression, okay? Or a third-party tool that does backup compression. Okay, so if you had a database where you set a really low fill factor because of the perf hit of page splits, I would really consider using backup compression, okay, when you're taking your full database backups. Okay. Okay. Lock escalation goes row to page, then page to table. True or false? Yes, absolutely. One of the most commonly held misconceptions. Lock escalation always goes from whatever to table. Okay, there's no intermediate steps. Now, in 2008, as it says there is a new thing called a partition level lock. So imagine you have a table with multiple partitions. So let's use some of my little stickers here. Okay. Buck, come here. We need another hand. Stand there and hold this. This is my beautiful assistant, Buck. Okay. So imagine we have 3 file groups. Okay. Each one is holding a separate partition. So if, for instance, somebody comes in and starts to do an update on the data in this partition, hits the 5,000 lock escalation threshold, okay, it's going to escalate to a table level lock. Somebody comes in, put your hand and point there. Somebody comes in with another query and wants to, for instance, select from this partition. They're blocked because of the lock escalation caused by the operation on this partition. So what 2008 allows is you can set the lock escalation for a particular table to be either none at all, table level, which is the default, or what's called auto, which says if you're using partitioning, escalate to our partition level lock. So under that same scenario, I come in and I'm doing my update over here on this partition, okay, and I hit enough locks, it escalates to a partition level exclusive lock. The table level lock stays as intent exclusive. So then the other query comes in over here and wants to be able to do whatever, right? It's not blocked because the exclusive lock is only on this partition. Now, you should be asking yourself, why isn't this on by default? There's a catch. Lift up your hand. Okay. If the query that... What are you doing?
This is the partition.
Okay.
I'm helping.
That's fine. Yeah, that's fine.
Okay.
That's fine. It should be kind of like that. It should be more like this. Yeah, okay. We're good. We're good. Isn't he great? Isn't he great? So imagine that I've escalated to a partition lock here, and I've escalated to a partition lock here, and then this guy says, oh, I want to read from here. And this guy says, I want to read from here. What do we have? Deadlock. Okay? So one of these guys is going to get killed. Right? Yeah. And it's always going to be Buck because I have a higher deadlock priority than Buck does. Okay? This is why lock escalation is not set to auto by default in 2008. Because some of the customers in the early adopter program, when we had this set to default in the early CTPs of 2008, found that their applications were getting deadlocks. Okay? You can keep that sticker and you can sit down now. Thank you. Yeah. Moving right along. Rebuilding a clustered index always rebuilds all non-clustered indexes. True or false? Yes. Yes and no. Okay? It depends which version you're on. So in SQL Server 2000, First of all, there was a bug in SP1, which meant that whenever you rebuilt a clustered index, it would always rebuild the non-clusters. Okay, this is one of the reasons this misconception exists. Secondly, if you have a non-unique clustered index in 2000, SQL Server is going to add another column, a hidden column, into the clustered index key called the unifier column. Right? And that serves to differentiate between two non-unique keys. Every row in an index must be unique, otherwise the storage engine would break. Now, if you rebuilt a clustered index on 2000, the index rebuild would regenerate these unifier values, thereby changing the cluster key essentially. Now, think about non-clustered indexes. A non-clustered index is what you create to allow the query processor to find the records for your select list as easily as possible. Now, if your non-clustered index doesn't have all the columns in your table, which it generally should not, then, in fact, it always should not, then, and your select list has more columns than there are in the non-clustered index, the storage engine has to go back to essentially what I call the base table record to pick up some of those other columns. How does the storage engine find which record to go and look for in the base table? Every non-clustered index has a linkage back to the matching base table record. If the non-clustered index is over a table that has a clustered index, that linkage is the cluster keys, because they're guaranteed to be unique. If the non-clustered index is over a heap, the linkage is the physical location of the base table record. So now we've got all these non-clustered indexes with the cluster keys in. What happens if the cluster key changes because of an index rebuild? All the non-clustered indexes have to get rebuilt. So if you rebuilt a non-unique clustered index in 2000, all your non-clustered indexes get rebuilt. That was fixed in 2005. Is Connor still in the room? No, he left. I was going to say thank you to Connor. So that was fixed. And so now what an index rebuild does on 2005 onwards is it keeps the unifier values. So your non-clustered indexes don't have to change at all. Okay. So there is no operation that you can do to a clustered index apart from changing the definition of the index somehow that will cause non-clustered indexes to be rebuilt in 2005 onwards. If you partition an index, you don't change the cluster keys. If you move an index somewhere else, you don't change the cluster keys. Okay? Question, whoever it was. Yeah? Hold on, I can't hear you. Good question. So the question is, if you move a database over to 2005 and you leave it in the 8.0 compat mode, would this behavior that I just explained for non-unique clustered indexes happen? The answer is no. The compat mode only changes certain query behavior. It doesn't change anything else about how the storage engine or anything like that works. Okay? And I think there's a myth in here about compat mode as well. Okay. Failure detection is instantaneous in database mirroring. True or false? It is false. Okay? It's marketing. It's a marketing myth. The speed of detection depends on what actually goes wrong. So the way that a mirroring failure is detected is the mirror and the witness, if you've defined one, are basically pinging the principal once a second. Okay? And if the principal does not respond, depending on what goes wrong, then a mirroring failure is declared. So let's look at some failures. So for instance, let's say the first thing happens. So Windows Server on the principal stays up, but SQL Server crashes. The first ping that comes in from the mirror, Windows Server is going to say, hey, there's nothing listening on this port. Okay? So you're looking at most 1 second before the failure is detected. But what if Windows Server crashes as well? Then there's nothing there to say there's nothing here. So then it's not until what's called the mirroring partner timeout expires. Now, by default, that's set to 10. It's the number of once per second pings that have to be not replied to before the mirror declares that the principal is dead, or it can't reach it. Okay? So then you're looking at 10 seconds. Now, you might have changed the mirroring partner timeout if you're using mirroring with, say, failover clustering. Okay? So you might have a failover cluster, and you're mirroring between the two. Okay? So you only want the remote failover to happen if the entire cluster over here goes down. You'd rather have a local failover. How many of you have clusters that can fail over in 10 seconds or less? 1 person, 2 people, yeah, give or take. Okay? Most clusters don't take 10 seconds or less to fail over. You might be lucky if you can get 30 seconds, maybe a minute or so, because all the databases have to go through crash recovery. Right? So in that case, if you left the mirroring partner timeout at 10 seconds, the failover cluster, one of the nodes would die, 10 seconds would go past, and the mirror would come up potentially as the principal, because there hasn't been enough time for the SQL Server to come up on one of your other cluster nodes for it to respond to the ping. So what you need to do, and best practice if you're going to combine mirroring and clustering, is you change the mirroring partner timeout so that it is longer than the time it takes your local failover cluster to effect a failover. So you might set it to, say, 90 seconds. So then case 2 on the board there, if Windows Server dies and SQL Server dies, it might be 90 seconds, for instance, okay, if your entire cluster goes down before the mirror declares a mirroring failover. Okay? Again, not instantaneous. Now let's say something goes wrong with a log drive on the principal SQL Server. So SQL Server carries on writing IOs. After 20 seconds, it puts out an error message in the error log saying, I'm not getting any IO completions. And it carries on for another 20 seconds, and after 40 seconds of not getting any IO completions on that log drive, it will take the database offline, and that is a mirroring failure. So then you're looking at 40 seconds. Now let's look at a case where a page has corruption on it. So let's say that a page has a bad page checksum. The IO subsystem, for instance, has corrupted it. If the page checksum failure is hit by a regular select, nobody cares as far as mirroring is concerned. Okay? You might get automatic page repair kicking in if you're on 2008, but it's not a mirroring failure. Now let's say that you've got a long-running transaction and you say rollback. The rollback starts undoing all the operations, and it goes to undo an operation on the page that has the page checksum failure. As soon as the operation tries to read that page checksum failure, recovery of that transaction that you're rolling back stops. The database is immediately thrown into the suspect mode. Okay, you have a transactionally inconsistent database because essentially crash recovery couldn't finish running. That's an instantaneous mirroring failure. Okay? So as you can see, detection of a mirroring failure is not instantaneous. It totally depends on what the failure is. Okay? Don't believe all the marketing hype. Now the other thing that was hype was failover is instantaneous in database mirroring. So that's obviously busted. Okay? The amount of time it takes for a failover to occur depends on A, how quickly the failure is detected in the first place, and also how much transaction log there is in the mirror's redo queue. So there's two queues of log records. There's one on the principal called the send queue. And the send queue is essentially all of the log records that haven't yet been sent across to the mirror. This can occur in asynchronous database mirroring. It can also occur in synchronous database mirroring if the mirror and the principal become unsynchronized for some reason. Maybe there's a transient network dropout. Okay. The amount of log records there are in the send queue essentially equates to your data loss if a mirroring failure occurs. The other queue over on the mirror is how much transaction log is there in the mirror that has been received from the principal but hasn't yet been replayed on the mirror database. Because remember, the way that mirroring works is it just has to send the log records over and the log records get written out to the mirror's log drive. Okay? They don't have to be replayed in the mirror database for mirroring to work properly. That replay goes on permanently in the background. So if for some reason the mirror can't keep up with all the log being sent over to it by the principal, there could be a steadily growing redo queue. One of the things that I find many people do not monitor when they have database mirroring set up is the size of the redo queue. They'll monitor the send queue, but not the redo queue. The redo queue essentially equates to how much downtime am I going to have once a mirroring failover occurs. Okay? So mirroring failover, not instantaneous. It totally depends. Okay? Myth number 13, a non-clustered index should be created for each column in the table. True. It does. It makes it very fast, as Buck's saying. No. You guys should all know this. Okay? Only the indexes that the query plans are actually going to use. Now, if you take over a database, there's a whole bunch of different things you should check. Okay? One of the first things is auto-shrink turned on? Right? One of the other things you should check, and then turn it off. One of the other things you should check is, are there any indexes that are not being used? Unused indexes, in other words, indexes that are not being used by the query processor to help with query plans, are essentially dead weight and overhead in your system. Because any index, any non-clustered index that there is on a table has to be maintained by the system. If you insert a new record in the table, if it's not a filtered index, then it's going to have a record in the non-clustered index. If you change something that hits that particular index key, you're going to have a record that has to change in the non-clustered index as well. Right? So you can use the sys.dmdb index usage stats DMV to figure out whether there are any indexes that are only being used essentially for updates. They're not being used for seeks, they're not being used for scans. Anything that is not being used for seeks or scans is a great candidate for being dropped. Now notice I said a great candidate for being dropped. Don't go and drop it straight away. You have to profile the output from index usage stats over an entire business cycle. Because you could have a report that runs at the end of the month, which needs a couple of these indexes. And if they're not there, it's going to run very, very slowly. You could have a CEO query, okay, that runs once a month. You don't want that to suddenly run slowly either. Okay? So use this DMV, and lots of people, me included, have written blog posts about how to capture the output of this and profile it. Use the DMV, but use it carefully. Okay? Tim. Yeah, so Tim makes a good point, which is that particular DMV, the information that comes from that DMV is cached. So the DMV only reports information since the last time that particular database was started up. So if the server crashes, you lose all your index usage stats. Okay? So this is why it's a good idea to persist them every so often. Okay. There's another question. Yeah. Hold on, I can't hear you. Is this DMV partition aware? No, it's not. It doesn't give you partition usage. Okay. I don't know of anything that will tell you when particular partitions in an index were used. Anybody else? Any DMV experts in here? The file stuff won't do it either. Yeah, there's nothing. Yeah, no, there's nothing that's going to tell whether it's a particular partition that's being used or not, whoever it was that asked the yeah. Okay. Connect.microsoft.com. There you go. Yes? Oh, if you fail over, you lose all of this, because this is per SQL Server instance. These kind of statistics are not copied over after a failover. Okay? All this stuff is basically held in SQL Server's running memory. So if you go to a different instance, it's different running memory. There's no extra copy of this stuff. Okay? Right at the back.
Operational status except partition ID as a part of the
So, so what Jonathan's saying is index operational stats accepts a partition ID, and will it give you? It'll give you seeks, scans, and updates as well, won't it? Jonathan's going to have a look. Okay, that might be a way around it. Okay, yeah. The what? Yeah, so anytime the database is shut down, it wipes out all the stats. Okay, so auto-close will do it as well. That's another thing you probably shouldn't have turned on, auto-close. All right, let's move on. 14, failover clustering is the best HA technology to use. True or false? Yes, absolutely, it depends. Okay. Unfortunately, many people, when they say, oh, we need some HA, will say, well, let's get a cluster. Okay? Or they already have a cluster, and then suddenly they want HA as well. Oh, we've already got a cluster here. A failover cluster is a great technology, but it has a massive Achilles heel. There's no secondary copy of the data. Okay? All it protects against is hardware failure of the server machine itself. It does not protect against failure at the data level. So if you're going to use a failover cluster, you have to have some extra redundancy at the data level. So you might be looking at something like database mirroring or log shipping, or if you've got multiple databases, some kind of SAN replication, maybe a synchronous SAN replication. Okay? But even that, failover clustering might not be the best solution for you. So the way to put together an HA strategy, you look at your requirements. So what are the service level agreements, basically the RTO and the RPO of all the things that you're trying to protect? Okay? What are the requirements in terms of performance? Okay? You might compromise performance by using a particular HA technology. For instance, if you start using synchronous database mirroring, then all transactions are going to have to wait for all the log records up to and including the commit record to be sent over to the mirror before it can acknowledge the commit on the local system. If all your transactions are very, very tiny and there's a lot of network latency, that's going to be noticeable. If your transactions are very large, then it's not going to be so noticeable. Okay? So requirements. In terms of the things you're protecting, what's the priority list? Now, your management's going to say everything's P0. Okay? You can't do that. Okay? There has to be a defined priority list because you may not be able to actually protect everything that's required. So you have to figure out what's the most important thing to the business. And that's a business owner's decision, what's the most important thing. Okay? Now, the RTO and the RPO, management's going to say 0 downtime and 0 data loss. Not possible. Okay? You can do 0 data loss. It's not possible to do 0 downtime. Okay? No matter what technology you're using, there is going to be a tiny amount of downtime, no matter what. Okay? So that's your requirements. What about limitations? Okay? So limitations in terms of non-technical means. That usually comes down to budget. Okay? There's basically budget and politics. Okay? So budget, things like how much space do you have? Okay? So if you need to have a bunch of extra servers, can your server room accommodate those? What about power distribution? I remember way back in the midst of time, we bought a whole bunch of test machines for the Building 35 SQL Server lab on campus. We found that our PDUs in the building couldn't handle the load. So we had all these machines sitting there until we upgraded the PDUs. Okay? So power. And then all these new machines you're going to put in generate heat. So you're going to need extra HVAC, which takes more space and more power. Okay? So there's all these kind of things you have to think about. If you've got a colo, okay, that's going to cost you money as well. What about security? All these people that are running the colo, are they security vetted to the level required for your data? Okay? All these things are requirements you're going to have to think of. So you've got limitations, you've got requirements, right? And then you're going to have to compromise because you're not going to be able to do everything that management requires. Once you have your compromised set of requirements, only then do you then start looking at technologies to see what they can and cannot do. And you're going to come up with a combination of technologies that's going to allow you to meet your HA strategy. Okay? Lots of information in a couple of white papers that I wrote for Microsoft. One last year, talking about high availability with SQL Server 2008, and one this year, proven SQL Server architectures for high availability and disaster recovery. A whole bunch of customer case studies with named customers and what they did and why they did it, and justifications of what they used each of the different technologies for. Okay. Clustering is not the best HA technology. It is one, but it's not the best. 15, concurrent data and log backups are not possible. True or false? Haha. Yes and no. It depends on which version you were using. So in SQL Server 2000, you could not do a log backup while a data backup was running. Because a log backup wants to clear the log. And data backups require log, as I mentioned earlier on. So if the log was cleared while the data backup was running, the data backup wouldn't be able to back up all the log that it requires. So in 2000 and before, your log backup would essentially just hang, waiting for your data backup to complete. In 2005, that was changed. I'm not going to say fixed, it was changed, such that concurrent log backups are possible with full and differential backups. Okay? But there's a slight behavior change. Okay? The log truncation that occurs is deferred until the end of the data backup. Okay? Now this gives rise to the next myth, which is a full backup allows the log to clear or truncate. True or false? Absolutely. Okay? So log truncation and log clearing, they're both the same thing. They're both horrible misnomers. Because when the log clears, nothing is cleared. When the log truncates, it doesn't change size. Okay? So log clearing and truncating just mean that 0 or more virtual log files inside the log are marked as no longer active. Okay? 0 or more. Just because you did an operation that can clear the log doesn't mean that any log actually cleared. Okay? So the two operations that clear the log or truncate the log, if you're in the simple recovery model, it's a checkpoint. If you're in bulk logged or full, it's a log backup. There are absolutely no exceptions. Now remember back to what I was talking about previously. If you're doing a full backup, and the full backup takes, say, 12 hours, you do a series of log backups because you're doing log backups every half an hour. When the full backup completes, the log's going to clear. Because the backup system knows that a log backup has occurred. It knows the LSN to which that log has been backed up by a log backup. And as long as that log is no longer required by anything else in SQL Server, that particular portion of the log can clear. So because at the end of the data backup, the deferred log truncation occurs, it looks like a full backup cleared the log. But it didn't. It was really the log backup, but it was deferred. Okay? You cannot run DMVs against a database in the ATO compat mode. True or false? Correct. Okay. Well, it depends. You can run the DMVs, but you have to be careful because there's some syntax elements that if you use it in the call to the DMV, you'll get a really, really instructive message saying incorrect syntax near parenthesis. Okay? For instance, if you use object ID as an embedded parameter, this is the one that caught me out. I was actually under this impression until about a year ago, okay, that you couldn't run them in databases that were in NATO compat mode. Okay? If you use one of these constructs, it will not let you. Okay? If you want to use one of these constructs in your call to the DMV, run the DMV in the context of a database in the 9.0 or higher compat mode. But DMVs themselves, you can run on a database in any compat mode. Okay? Now, compat mode versus physical database version. I don't think I have a myth in here about that. A lot of confusion about what these mean. The compat mode of a database has absolutely nothing to do with the physical version number of the database. Right? The physical version number of the database is dependent on the SQL Server version that the database is attached to. Okay, so for instance, if you're running 2005, it's 539. Okay. No, 2000 is 539. If you're running 2005, it's 611. Okay. If you're running 2005 SP2 with var decimal, it's 612, and so on and so on. Okay. When you upgrade a database, or you attach a database to a new version and it upgrades itself, you'll see a bunch of messages saying, running this upgrade step from this number to this number. And you'll see a whole bunch of them. Every one of those steps is bumping the physical version number of the database. Okay? This is why you have problems when you're trying to restore to older versions. Now, the physical version number defines which SQL servers you can attach that database to. Okay? The compat mode has nothing to do with that. It just defines the behavior of certain older query syntax. That's all compat mode does. Okay. How the what? Yeah, bugs saying anti-nulls and bits and bobs like that. Query stuff. I don't do query stuff. I do storage engine stuff. The compat mode doesn't change anything to do with the storage engine at all. Okay. Is that true? Yes, that's true. Yep. Okay, myth number 18. You can cause corruption using a T-SQL statement or interrupting a long-running T-SQL statement. Commonly cited examples are long-running shrinks and rebuilds. Now, we're not talking about 6.5 here. Okay? 6.5 was a corruption machine. So, true or false? Busted. No, you cannot. Okay? Nothing you can do with SQL Server will cause corruption, unless there's a bug in SQL Server. Okay? There have been plenty of corruption-causing bugs on every release of SQL Server. It's an enormous software product, just like there's been plenty of bugs that have caused blue screens of death on Windows. Okay? They're not deliberate. It's just whenever you have humans writing millions of lines of code, you get problems. Okay? Corruptions are caused, in the most part, by your I/O subsystem. Of all the thousands of cases of corruptions I've seen, I'd say 99.999% are caused by the I/O subsystem. Okay? The other 0.005% caused by bad memory chips. The other 0.005% caused by SQL Server corruption bugs. Okay? Now, if you think about what the I/O subsystem is, it's not just the hardware. Right? So your I/O comes out of SQL Server's buffer pool. It goes through the operating system, filter drivers, potentially network drivers, SAN controllers, RAID controllers, disk controllers. Each one of these things has more lines of code than SQL Server has. And what did I say? Anytime you've got code written by humans, you have the potential for problems. Okay? So the I/O subsystem is what causes the overwhelming majority of corruption problems. Okay? Myth number 19. You can restore parts of a database to different points in time. Yes, false. Okay? You cannot. So anytime you restore any part of a database, now, read-only portions of a database are a kind of special case, okay, because they're read-only. But anytime you restore any read-write portion of a database, it must be brought up to the same point in time as the primary file group. There is no exception to this. Okay? Otherwise, you'd have all kinds of weird corruption problems, potentially, especially if you had relational integrity between different file groups and so on. You also can't do what I say there. Basically, kind of the same thing as Oracle's transportable table spaces. There's no such thing in SQL Server. You can't mix and match file groups. Okay? You can do some cool things like, for instance, if you've got a very large production database and you want to transport portions of it to a dev system, as long as your database is set up with varying file groups, you can do file group level backups of that database, and you can do a partial restore of that database onto a dev system. So you restore the primary file group, you say with partial, which says to the restore system, I'm not going to restore the whole database. You restore 0 or more extra file groups, then bring the database online. Okay? And only the portions of the database that you've restored are there and online. Okay? You can restore or attach a database to an earlier version of SQL Server, e.g. 2005 database to a 2000 server. True or false? It is false. Okay? It has never been possible, okay? And it likely never will be, because of the physical version number thing that I just explained. A backup knows, okay, or a database knows what physical version it is. Okay? You're not going to be able to do that. Now, one of the very good reasons for that is because the transaction log and what's put in the transaction log can change from release to release. So, for instance, in 2005, there was a whole new set of information added to every transaction log record. And this was the locks that were held at the time that the operation occurred. Okay? So there's a bitmap of which locks were held on which particular resources at the time that log record was generated. These are used to allow fast recovery to occur. So on Enterprise Edition, if you attach a database and it's running restore, for instance, or crash recovery, well, actually not when it's running restore, crash recovery occurs, then you can get into the database before all of crash recovery has occurred. Basically, you can get in after the redo phase has occurred, but before the usually longer running undo phase has occurred. I see you. I'll take the question in a second. The way this works, I said I'll take it in a minute. Yeah. The way this works is the log records have the locks that were required in them. As the system is running the redo portion of recovery, actually crash recovery makes 3 passes through the transaction log. When it's doing its second pass to do the redo portion of recovery, it's looking at all the log records that it knows it's going to have to recover for the undo portion of recovery. It looks at those locks and it goes and acquires those locks. When you're running fast recovery, it allows you into the database as soon as it's finished doing redo, because it knows that it has all the locks necessary to be able to do all the undo. And nothing you can do in the database will stop it being able to do undo, because it already has those locks. So because the log records have extra information in them, if you try to make the SQL Server 2000 engine understand those log records, it would just barf nicely on the floor. Actually, it probably wouldn't be very nice. Okay. So there's a question somewhere. Hold on, I'm going to have to come over to you because I'm not going to be able to hear you. Run, Forrest, run. Yes? You didn't. Whatever you thought you... So what she's saying is they had a situation where they had 2008 databases and they backed up and restored them to 2005. And I'm saying whatever you thought you did, you didn't. It's not possible. Yes, my guess would be that either it wasn't attached to a 2008 instance or upgrade hadn't run for some reason. But what you describe is not physically possible. Absolutely, 100%. I believe that that's what you think you saw. But that's not what happens. It doesn't matter who you have that says they did it. You can't do it. Okay? You can talk all you want. It's not possible. It's absolutely not possible. Okay? I've seen cases in newsgroups where people think they've done this, and there's been some other thing that's occurred that means it didn't actually get upgraded. Okay? Once it's a one-way step. You cannot take it back. There's no way. You can't do that. You can't. But that's compat level. But that's not physical version. They must. But that's orthogonal to database physical version. Yeah. But what you saw didn't actually occur. Okay? Sorry, this is the way it is. Okay? Okay. As it says there, once you've upgraded a database, it's a one-way version, a one-way operation. The only way to get it back is export your data out and import it into a new database. Okay? Nested transactions exist in SQL Server. Yes. Totally false. This is a joke perpetrated by the SQL team on all your developers. Okay? The joke is that if you do begin tran, do some stuff, begin tran, do some stuff, and then do commit tran, what you expect to happen is all that stuff that happened in the inner transaction is now actually committed. That log can clear. No, that's not how it works. All that commit tran does is decrement at tran count. It doesn't do anything else. Okay? As it should. Yes. Yeah. So until you actually do the commit that decrements at tran count to 0, everything in the context of the outer transaction is not committed. Okay? Now, what's even worse is if you do begin tran, blah, 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 begin tran, blah, 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 begin tran, blah, 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 rollback tran. It rolls back to the top. Okay? This is why this is the joke. Okay? I have no idea. It's query processor crap. I don't know. Find Connor and ask Connor. Okay? It's not storage engine stuff. It's been there since year dot. It's one of these things. It's like the full recovery model being the default, which catches involuntary DBAs out. It's like with recovery being the default on a restore. It's just there, unfortunately. No, I wouldn't blame Sybase. I think this stuff was put in after we got the original code from Sybase. I did, but I'm honest, see? I might not look it, but I am. Okay? See, Buck looks it, but he isn't. Okay? Because they thought it was funny. It's called a joke. It's a joke, see? Yeah. Yeah. And they believe me as well, see? Yeah, exactly. I'll explain it to you later, don't worry. Okay, file stream data can be stored on a network share, separate from the instance where the SQL Server is running. False, yes. Now, I can imagine why this misconception comes around, because one of the access levels of file stream data, access level 3, is allow local T-SQL access, allow local access through the file stream mechanism, and allow remote access through a share. Okay? And it's this remote access through a network share that confuses people. The actual file stream data container itself must adhere to the same locality rules as the database data files in terms of where they're located. You cannot store it on a network share. It must be on files attached to the local SQL Server. Jeff?
Isn't there a trace flag that allows you to store SQL on mask?
There's a trace flag that allows you to store data files on network attached storage, but that doesn't apply to FileStream. Bonus points and a free sticker if anybody knows the trace flag off the top of their head. The exact trace flag number, Denny. Yeah. Denny's very rude, everybody. Yeah. Okay. Yeah, that's not news to me. Myth number 23. Turning on-page checksums protects all your data immediately. True or false? Yeah, this is another joke by the SQL team. Okay. Unfortunately, I helped perpetrate this joke. It doesn't do anything. Okay. Page checksums are fabulous, but it's a bit of a quirky way that they're implemented. So if you create a database on 2005 or on 2008, then your database is protected by page checksums. Now, even saying protected is a misnomer, because if you have page protection turned on, the I/O subsystem doesn't go, oh, that page is protected, I better not corrupt that one. Okay? So page protection really isn't. It's really easier way for you to detect corruption. Okay? So with torn page detection, what that does is, it's pretty cool. If you think of a particular page, an 8K page, is 16 contiguous 512-byte disk blocks. To be able to write out the page, all 16 have to be written out at once. Imagine you have a disk drive that has issues with its battery backup. The power fails. It's in the middle of writing out a page, and boom, it stops. So you've got half of the new page and half of the old page. That write is called a torn write, and so you have a torn page. Okay? SQL Server can detect this by, when it writes out a page, putting an alternating bit pattern on every sector of the page. When it reads the page back in, it should get an alternating bit pattern all the way down. The bit pattern flips every time a page is written. So if a torn page ever occurs, when it reads in the page, it's going to find 2 consecutive sectors with the same bit pattern. Okay? That's all very well, but it doesn't allow SQL Server to detect when something has scribbled in the middle of a page, which is why page checksums were put in 2005. what page checksums are is whenever a page is written out, it's a very simple checksum that's calculated over the page. It's not an expensive kind of CRC-based checksum you get in a network stack. That would cause perf issues. So a very simple checksum stamped on the page. It's written out. When the page is read back in, the checksum is checked again. If the two numbers match, everything's cool. If the numbers don't match, proof the I/O subsystem corrupted the page in some way. Okay. Now, unfortunately, if you upgrade a database from 2000 to 2005 or 2008, then turn on page checksums, alter database, set page verify checksum, nothing happens. It's not until a page is read into the buffer pool, changed, that's the key point, and then written back out that it has the page checksum put on it. So simply selecting all your data won't do it. Doing a backup and restore won't do it, because backup and restore is a purely physical operation. Doing a checkDB won't do it, because that's just reading the pages. Okay? You would have to do something like, update all the records in your tables, index rebuild of all your tables. But even that's not going to get the system tables, it's not going to get all the allocation bitmaps potentially as well. Okay? There is no tool that we put out when we put in 2005 to go and touch every page and force page checksums on. You can brute force it. If you turn on transparent data encryption, that will go through and it will put encryption on every page, and it will put a checksum on every page. And then you could turn off transparent data encryption again. Okay, but that's a pretty brute force method. And remember, when you turn on TDE, you lose instant initialization. Okay. I've been experimenting for a few years trying to figure out some kind of backdoor way of doing it with undocumented DBCC commands, but I haven't figured out a good way of doing it yet. But anyway, when you turn it on, nothing happens. 24. You can avoid running checkDB as long as you use backup with checksum. Yes. It sounds like you could. Okay, if you do a backup with checksum, it's going to test all your page checksums. Okay? But what if the page was corrupt when it was written out to disk? So imagine you have bad memory chips. A page might get corrupted in SQL Server's buffer pool. Then it gets written out by a checkpointer or the lazy writer. A checksum is put on it. The checksum is perfectly valid. But the data that it's checksummed is corrupt. A backup with checksum will say, yes, this looks like a good checksum. The only thing that's going to detect the page is actually corrupt is checkDB. checkDB is just wonderful, remember? Okay. Now, if you don't have bad memory chips, okay, it could be a SQL Server corruption bug. It could be something in Windows is scribbling in SQL Server's memory space. Okay. Now, SQL Server can detect this. There's an error that you might get called 832. Not 823, which is an I/O error, 832. You never want to see this. Okay? Horrible. What this is the lazy writer, which is basically a clock hand going round and round all the buffers in the buffer pool, kind of proactively flushing out buffers to disk to make space in the buffer pool. The lazy writer, if it comes across a page that has not changed since it was last read in from disk, and it has a page checksum on it, it will test the page checksum. And if it finds that the page checksum is invalid, it'll raise error 832. And error 832 says you've got bad memory chips or there's a memory scribbler happening on your OS. Both of these are incredibly difficult to track down. You're going to be working with product support. Okay? And see, as it says there, checkDB is wonderful. Okay? It's on the slide. It must be true. It is possible to have multiple mirrors of a database with database mirroring. True or false? Before SQL 11. Okay? False. One mirror. You can't have chaining either. You can't have principal to mirror, and that's a principal for another mirror. Right? If you want to have multiple copies of your databases, you're going to have warm copies using log shipping. Very common to see that. A database mirroring principal and is also a log shipping primary. Right? But you can't do it with mirroring. DDL triggers are instead of triggers. True or false? Haha. False. They are after triggers, which makes DDL triggers actually not quite as good as they appear. Because what happens is it does the thing, then the trigger fires, and if you put a rollback in your trigger body, it rolls it back. Okay? But you can't stop the thing from happening at all. Okay? Which is why it would be great if DDL triggers were instead of triggers. So all your PBM policies, okay, are using DDL triggers. So the thing will happen, and then it will roll it back. Okay? Beware. Select count star will always use a table scan. True or false? Yes. Select count star will use the smallest structure that there is, which is usually the smallest non-clustered index. Okay? as long as it's not a filtered index. Okay? It's always going to pick the thing that has the smallest number of pages so it can do the smallest number of IOs. Now, unfortunately, the buffer pool, the query processor has no idea what's in the buffer pool. So it could be that you already have an index in the buffer pool completely that would allow a select count star to be done. Okay? It is still going to pick the smallest index and issue IOs over that. Okay? Yes? Select count 1. I've got no idea what that does. What does it do? Select count 1? Really? I imagine it would do the same thing. Okay. Why would you do a select count 1 though? See, this is daft query processor stuff. You know, storage. There's always been, in the SQL team, there's always been this kind of between the query processor and the storage engine. If I ever draw a picture of how SQL Server looks, then there's query processor, storage engine. Okay. What's there? Oh, and that's what the 1 means? Buck's saying something and I don't really understand it, so I'm not going to repeat it. Okay. She does actually, yes. I know, his wife does say that all the time. Yeah. 28. TempDB should be a certain percentage the size of your biggest database. Variations on that talk about the log or autogrowth. True or false? Yes, it's absolute BS. Okay? The information you'll see on the internet where somebody says, oh, I think your database, your TempDB log or something, or your TempDB should be 50% the size of your biggest database. That's because that's what it worked out to be for them. Okay? There's no hard and fast number. There's no hard and fast guidance in terms of a number or a percentage that's given out by Microsoft, that's given out by the CAT team or anything like that. Okay? There's a methodology that you can follow because there's no right answer what that should be. So let's have a look at how big should your transaction log be. Okay? The transaction log has to encompass the single largest transaction that you do in your database, which could be an index rebuild in the full recovery model. It could be a bulk load operation or a massive update. It also has to be able to encompass all the transaction log that occurs between your log backups. It also has to encompass all the log that can occur while your largest data backup is occurring, because your data backups won't complete. So your data backups won't allow the log to clear. Okay? If you have HA technologies, that could play into how much transaction log you have to keep around as well. There's no hard and fast number. There's methodologies for figuring this stuff out. There's plenty of blog posts out there that people have done that talk about the methodologies. Okay. In-flight transactions are preserved after a failover. True or false? False. The only time this happens is if you're using some kind of virtual machine that supports live migration and the live migration's been set up in advance. Okay? Then your connections and your transactions migrate as well. Everything else, crash recovery is going to happen. So your in-flight transactions are lost. Okay? Now, it's past. Okay? Don't forget, this is a 90-minute session. Okay? We have 15 minutes more to go. Okay? Don't walk out yet. Okay? There's some more cool stuff. Isn't that a great picture of Buck? Okay? I'm happy for Buck Whitty to leave. Anytime at all. Okay? Bye, buddy. Oh. Hands up who thinks Buck should be allowed to stay. Yeah, come on, you can stay if you want. He actually has a meeting to go to. Knock him dead, Buck. All right, myth number 30. It's not possible to analyze the transaction log using SQL Server. True or false? Busted, yes. You can use these various commands to do it. Now, dbcc log's the old way of doing it. Okay, there's a new function, well, new from 2000, called fndblog. fndblog kind of behaves like a DMV. It's nice and composable. You can give it a select list. You can give it a where clause. Okay? Lots of information out there by various people on how to use fndblog. There's a nice Google query you can use to find all the blog posts that I've done about using fndblog. There's actually an even cooler one, and this is all undocumented. There's an even cooler one called fn_dump_dblog. And that allows you to dump the transaction log from a log backup. Okay? So if you have somebody that dropped a table, and the drop table occurred at some point maybe last week, and that log doesn't exist on the server anymore, but it is in your log backups, then you can use fndumpdblog to look through those transaction log backups to find the transaction that did drop table. Okay? And there's information about how to do that out there on the internet. Okay. 31. You can restore a database backup to an earlier version of SQL Server. Actually, I'm just kidding. Haha, I got you. It is not possible. It is never possible. Okay? Now, don't you get great error messages when you try this? Look at this. This is the error message that you get when you try to restore a 2008 backup on a 2005 system. You get an error message about a media family. If you try to restore a 2005 backup on a 2000 system, you get error 602, could not find row in sysindexes. I mean, that just screams, I'm sorry, this is the wrong version, doesn't it? Okay? No. So we've already done this one to death. Okay, this is why I put it in. Okay. 32. Restarting SQL Server will fix database corruptions. Well, kind of. 3 times ever I have seen it work. And that's when the I/O subsystem and SQL Server were rebooted. Okay, it is possible rarely to have I/Os that just get stuck somewhere in the software stack in the I/O subsystem. They just cannot complete. Okay? So the fact that the I/O can't complete makes the database look like it's corrupt. By restarting everything, the I/O essentially completes, and the database magically is not corrupt anymore. However, 3 times I've seen that. Did any of you ever seen that? No. I've only ever seen it 3 times. You've seen it? Yeah, maybe a handful of people have seen this. Okay? Most of the time, you are basically just wasting your time. Now, saying that I've seen it a few times, would I ever recommend this as a course of action to people in general? No. Okay? It's so rare. And we're talking about 3 times out of thousands of cases of corruption. Okay? I wouldn't do that. Okay. 33. There is no way to find out the physical location of a particular record in a database. Correct. Okay. There is an undocumented function called %%physlock%%. Okay? And if you want to find out a particular record's location, maybe you are troubleshooting some corruption, you want to figure out what the range of records is that you're going to lose if you run CheckDB with repair and it deletes what's broken, then you can use this syntax to try and figure out the range of records you're going to lose. Okay? Very useful. You're not going to be using this unless you're doing some kind of deep troubleshooting like that, but it is there and you can play with it. And there's a blog post I've done that shows you how to play with it. Okay? 34. It's not possible to figure out what the lock resource is for a particular record to help with deadlock debugging. True or false? False again. Okay. There is another undocumented function called %%lockres%%. Okay. And you can use that to figure out a lock hash value. And we have some time, so I'm going to do a quick demo. Okay. I didn't know if I'd have time to do it or not, but we will. So this is a demo using a scenario that was originally blogged about by a guy called James Rowland Jones, who I think is here. Is he in the room, James? No? Okay. And he's a guy from the UK, and he blogged about this. So what I'm going to do is I'm going to set up a table. Very simple table with a bunch of different columns. I'm going to create a clustered index on it. I'm going to turn on my trace flag to look at deadlocks. Now, I'm over in connection 1. I'm going to insert some values inside a transaction. Connection 2, I'm going to insert some other values. And I'm blocked. Okay? Now, look at the values that I'm inserting in this connection. Okay? So 24271, blah, blah, blah. Now, over in connection 1, I inserted this value, 34245, blah, blah, blah. Now, do these values match any of these values? No. Why am I blocked? Okay. The reason that I'm blocked is because there's a bug before 2008 R2 in the lock hash generation algorithm. It is possible to get bogus lock hash collisions. So any time that there's a lock on a particular record, the key values are all hashed together into a 4-byte number. Right? It's possible for there to be lock hash collisions where there shouldn't be a lock hash collision. Right? I am now blocked here where I shouldn't be. Now in 2008 R2, the lock hash algorithm algorithm was rewritten, so it's now a factor of 100 million times less likely that this occurs, okay, according to the SQL team. But I'm now blocked. So I go back over to my connection 1, and I try to insert this value, which doesn't match anything over here. Deadlock. And one of them got killed. Another bogus lock hash collision. Okay? So let's have a quick look at this. Let's finish the transaction over here. I'm going to show you using this undocumented command. So what I'm going to do now is I'm going to create another table. Okay? I'm going to insert these values that were playing into my deadlock. And I'm going to use this undocumented command to look at the lock hash. So here's my undocumented option, %% lock res. Now look at this. This row and this row have the same lock hash. And I'm running 2008 SP1. Okay? But the values are completely different. This row and this row have the same lock hash, but the values are completely different. Okay? The only way to fix this is A, update one of the records, which isn't always possible, or add another column. Right? Add a column that will change the lock hash for both of those. Isn't that interesting? Right? And you might think, wow, this is never going to happen in production. I've seen this happen at a handful of our customers in the last year. Okay? Bogus lock hash collisions. And they're incredibly hard to figure out. Because you look at the numbers and you say, well, how the hell can this possibly be a deadlock? Okay? Or why am I blocked here? It could be because of this bogus lock hashing. Okay? Pat? It's going to no, just the index keys.
Okay, so when you say add another column, you're saying add another column.
Add another column. Yeah, good point. Add another column to the index key.
So that it
yes. Yeah. Isn't that interesting? All right, back to the slides. All right, so we've done this one. The last myth I'm going to do in depth. Okay. I spent more time working on CheckDB than being married to Kimberly. True or false? True. But it wasn't as much fun. I actually have to say that or I get in trouble. She's got 3.5 years. I spent 5 years on CheckDB. Okay. So we're almost done. Okay. Got a few more slides with some myths. Let me see. Repair cannot fix everything. There are a bunch of different things that repair can't fix because it can't do 100% provably correct repair. Repair can't sometimes work and sometimes not work. It has to always work. So for instance, a PFS page header corruption cannot be repaired. System table corruption cannot be repaired. Okay? Repairs are not replicated. Repairs are purely physical operations. If you repair something on a table that is part of a publication, the repair is specifically marked not for replication. And repair operations will specifically not trigger merge replication triggers either. Okay? If you have anything that's repaired as part of a publication, you must reinitialize your replication topology. Resource governor does not govern I/O. It governs memory and it governs CPU. It's unfortunate it doesn't govern I/O. It would make it really useful, for instance, for TempDB if it governed I/O as well. Right? Resource governor governs buffer pool memory. No, it doesn't. Okay? It only governs query execution memory grants. It doesn't have anything to do with how much data your query is reading into the buffer pool. So it's quite possible you could do a select that doesn't use very much memory that actually flushes out the buffer pool. Okay. Performance. You can override MAXDOP. So if you set MAXDOP to 1 because you're having parallelism issues, anybody at all can specify MAXDOP something else. You don't have to be SA to do that. Okay. Performance. Always use data compression. And this is a kind of it depends one. Right? Data compression is purportedly a data warehousing feature. And the reason it's not meant to be an OLTP feature is because if you have data that's being read and written and updated an awful lot, you're paying a lot of extra cost in terms of CPU. However, there are plenty of customers with a lot of CPU headroom that have found that data compression saves them an awful lot of space and also doesn't really slow things down because I have enough CPU headroom. Hey, Jonathan, what? Shut up. So Jonathan said, is replication an HA feature? So I just did a blog post last week, 2 weeks ago, called In Defense of Replication as an HA Feature. And replication is not a traditional feature that you think of for HA, but if, with all its various limitations, it works for what you want to do to make your data, that particular portion of data, more highly available, then it's an HA feature. Okay? Denny? How many CPUs do you have, and what's your I/O subsystem speed?
7,000 I/O per second, 12 points.
1 hour, 12 and a half minutes. There you go. And there's some more, lots more internals. Let's see. Shrink does not affect performance. That's obviously a myth. Okay. Keep the log as small as possible. No. Allow the log to get to whatever is its steady state size. Okay. Just yesterday, I had a question from somebody who's here at PASS, saying, I've been advised by Microsoft product support, okay, to shrink my log after every time I do my regular index maintenance and then allow it to grow again. Oh my God. No. The log cannot use instant initialization. Okay, the log always has to be zero initialized. I did a blog post that explains why it kind of plays into crash recovery, why the log always has to be zero initialized. Okay? You can't remove log records from the log. Okay? Anytime you roll back a transaction, it doesn't remove the log records for that particular transaction. It actually generates more log records, because everything you do to a database must be logged. So if you roll back a transaction, you are actually doing more changes to the database to make the net effect of that transaction no changes. Okay? The null bitmap only contains bits for nullable columns. It used to be in older releases. The null bitmap now has a bit for every column on the record. Okay? Truncate table absolutely is logged, but it is minimally logged. The deallocations of pages are logged. There are no non-logged operations in user databases. There is a single case where operations are non-logged, and that is anything to do with the version store in tempdb is utterly non-logged. There's no need for it to be logged at all. Okay. So, summarizing, there's an awful lot of misconceptions out there that you can read about. If anything seems fishy to you or you see conflicting information, give it a try, rather than believing one versus the other. Okay? One of them is obviously going to be wrong if it's conflicting information. Don't believe everything you read out there on the internet. Go to reputable sources. And with that, I am done. So please, I'll hang around. It's lunchtime. I'll hang around for questions. Thank you. Oh.